Well, hello. Here I am again, and what I'm going to try to do to you today is to explain periodic trends. Now, I've got a couple of diagrams here, and this first diagram, this one right here, I like this diagram. You probably already know that because I gave this to you and you have it in your notebook. And I know like that diagram. And just look at that diagram. What is confusing about it compared to this diagram right here? Okay, all the arrows in this diagram are going in a uniform direction. When we start talking about periodic trends, typically we talk about going across a row, and going across a row goes from left to right. And we talk about going down a column. And this diagram up here, we've got arrows going all over the place. And so I'm going to ignore that. Now, I gave you a template. And I'd like you to have that template out, and I would like you to have a periodic table out. And let's go after this. Alright, so here's the template. And what I'm going to try to do is we're going to talk about these properties here. If I can get my pen going. We're going to talk about atomic radius. We're going to talk about ionization energy. I think we're going to pass on electronegativity, and we'll talk a little bit about cations and anions. So first off, in your table you've got a column here that talks about the definition, what the property means. Now, atomic radius is pretty simple. It simply means the radius of an atom. How big is the atom? And we figured out already that the size of an atom is going to be determined by how many energy levels are in the electron cloud. Okay, so that's the radius of an atom. Ionization energy, simply put here, it is the energy that's needed to remove an electron from the atom. And what you've got here, an example, you've got sodium plus 496 kilojoules is going to produce a sodium ion, and you get an electron. And if we wanted to take more than one electron, the next statement here, it says that ionization energy increases for every successive electron that's removed from an atom. And I'm thinking we'll probably talk about this next Tuesday or Monday, one of those days. Electronegativity is something that's going to be very important when we talk about bonding. And I know we're not going to get into bonding until after Christmas, so I'm thinking I'm going to wait on the electronegativity and we'll deal with it after Christmas. Cations are a positively charged ion. Again, a cation or an anion, which is negatively charged, forms when an atom loses or gains one or more electrons, and depending on how many electrons I gain or lose, that will tell you the number of the charge. Okay, so those are my definitions. Now, the trend on the periodic table, and again, I am always going to go from left to right. That's going that direction, and I'm going to go from top to bottom. For atomic radius, it says here that it decreases as I go across a period. So as I go from left to right on the periodic table, along a row, atoms get smaller. And as I go down a column, they say they increase as you go down a group, so that means that the atoms are getting larger. And you might think to yourself, why? Well, the explanation here, as I go across a periodic table, electrons are being added to the same energy level. And what they're experiencing is an increased attraction to the nucleus, because as we keep adding electrons, we're also going to be adding protons. So the nuclear charge, the the strength that the nucleus is attracting these electrons with is getting larger. That causes them to pull this outer level closer to the nucleus. So the atoms, in a sense, get smaller. And we'll see that in our graph. Going down, I'm adding an energy level. Each row I go down the periodic table. So that's pretty simple. It means your atoms are getting larger. For the second, for ionization energy here, as we go across a period, it increases. And as I go down a column, it decreases. So when we say it's increasing, sorry about that, it means it's getting more difficult. I have to supply more energy to take an electron away from an atom. So what's going on? Well, it kind of relates to what happened up here with atomic radius. That the atoms are getting smaller, therefore it must be harder to remove an electron because it's closer to the nucleus. Going down, the outer electrons are farther away from the nucleus, which makes it easier to remove electrons from. And that kind of makes sense too. And then, again, I'm going to skip electronegativity for a cation. Cations are smaller than the atom from which they formed, which means the positive ion is actually smaller than the atom it forms from. And you might think, well, why is that? Well, when we lose electrons, we decrease the size of the electron cloud, which causes the radius of the atom to get smaller. And just the opposite is true here. Anions, or the negative ions, are larger than the atom from which they form because you're gaining electrons. That causes the electron cloud to increase in size. Okay, so those are the trends that we're going to be, most of the trends we're going to be talking about. Okay, so here you have a problem. You've got calcium, strontium, barium, and magnesium. These are the four atoms that we want to consider on the periodic table. You will notice that these are all in group 2. I'm not sure why my pen is not writing, but such is life. And so we have some questions here. Which element, calcium, strontium, barium, magnesium, would be most metallic? Well, we said that metals were located on the left-hand side of the periodic table, and the most active metal is francium, which is down at the lower left-hand corner. And so as you go down a column, metals tend to get a little bit more active, and so the one at the bottom here would be barium. Which would be least metallic? Well, that would be at the top. That would be magnesium. Lowest electronegativity? Don't answer. How about highest ionization energy? Well, we said ionization energy increases as you go across a row, but we're all in the same column. It decreases as you go down a column, so which would have the highest? Yep, magnesium. Which would have the largest atomic radius? Well, atomic radius increases as we go down. That would be barium. Which are nonmetals? I would say none. Which are conductors? All. Metals are all good conductors. List them in order from small to large. Well, we would go from magnesium, you go to calcium, strontium, and barium. Would they gain or lose electrons to form ions? Metals? Yep, that's right. Metals lose electrons. They would actually become positive ions. And you know how many they would lose? What charge would the ion have? They would lose 2 electrons. I can make a 2. Thank you. So it would be plus 2. Would the ion be larger or smaller than the atom? Well, think about that. If we're losing 2 electrons, it's going to be right. smaller. Would the ions be cations or anions? They would be cations. And what's the special name given to this group of elements? Look on your periodic table. We talked about it today. The alkaline earth elements. And what are some characteristics of this group? Well, look at the properties that they have there. Okay? And here's another problem. Here you've got 4 elements: silicon, sulfur, aluminum, and phosphorus. And these are all in the 3rd row. Okay, so now we're talking about a row. Which one would be the greatest metallic character? Of all those, I would say probably aluminum. It is the one that's farthest to the left. Highest electron affinity, we're not talking about that. Lowest ionization energy, that would probably be aluminum, because ionization energy increases as we go across, and that aluminum is on the left hand side. The smallest, well, the smallest would probably be sulfur. It's the one that is on the farthest to the right. Which are metalloids? I think silicon. If you look at the location of silicon, and remember you have that stairway on your periodic table, list them in order of increasing size from small to large. That would be sulfur, it would be phosphorus, it would be silicon, and then it would be aluminum. Which are nonmetals? Nonmetals would be phosphorus and sulfur. Lowest electronegativity, again, we're not talking about that. Which would rather gain electrons? Phosphorus and sulfur, they're the nonmetals. Which would rather lose electrons? Silicon and aluminum. Which would form cations? Silicon and aluminum, they are the metals. Whoops, there you go. And which would be larger or smaller than the neutral atom? Well, larger, that would be the cations. That is going to be phosphorus and sulfur. And which would be smaller? Silicon and aluminum. Which ones would form anions? I think we said that already. Whoops, sorry about that. Sulfur and phosphorus. And would these be larger or smaller than the neutral atom? These would be larger. I think I read that question wrong up here. We are going to be working with the dynamic periodic table. We're going to make some graphs of elements 1 through 20 and see what we think of the data here. So, if you've got questions, come to class and ask them. Thank you.